My name is Ángel Cardama. I'm a professor at the Universitat Politècnica de Catalunya, and we are going to discuss some interesting cases in wireless communications. And today we're going to talk about radio broadcasting, and I propose you to start solving this problem. Is studying an FM broadcasting station, and you have here the basic parameters for the station. This is just the tower, one of the examples of towers. They have antennas along this, and those towers could be really quite simple or complicated depending on the power, the number of antennas, and they could really have a coverage more or less up to the horizon. And here you have a small receiver that has some bands. It has an extendable antenna, which fully extended is just about 1/4 wavelength, and you can in some way orient it to receive the antenna, to receive the signals. Now the parameters for the link is you just broadcast at 100 megahertz in one of the bands assigned for broadcasting, and the radio station is a 1 kilowatt, has a 1 kilowatt power transmitter. The antenna is in this case is a simple one, is a 5 dB gain antenna. Could be different depending on the coverage you want, but always those systems want to cover all directions on the plane, on the ground. And if the antenna doesn't have too much gain, they could also be radiating up in the air. So probably in this case, with those numbers, if a plane was flying nearby, you could also tune to that FM station. The receiver has a simple antenna. It's a 2 dB gain antenna, and is located 50 kilometers away from the transmitter. And we say that it's under line of sight conditions. That means that the antenna is somewhere around there on the mountains and could see the transmitter, and there was no obstruction. But still those signals can propagate beyond the horizon, but not very far away from this. Now, to make things simpler, we assume that the total noise temperature of the system is 10,000 Kelvin. This includes the antenna, the noises, and all the surrounding noise around the receiver. And we assume that this radio here has a gain on the first stages of these receivers of 15 dBs and a noise figure of 10 dBs. You also need to know the channel bandwidth for an FM station radio, which is 200 kilohertz typically if it's stereophonic. In the case of monophonic, could be 100, but that's the typical value we're going to take. And you need the wave impedance. And with all those numbers, now what you have to do is to find how much power this radio will be receiving when it's placed 15 kilometers away from the transmitter.